Welcome to this week's episode of Follow a Researcher. As we learned last week, the Earth is made of systems where a change in one aspect of a system can translate into sometimes huge effects in another aspect of the same system. As scientists, we make observations, and afterwards we consider what may be the causes for the effects that we're seeing. One simple example of a cause and effect chain can relate to anomalous or unusual weather in a given area and how that can affect a system within that area. For example, when we receive too little rain on my family's farm in Wisconsin, that could lead to slower or stunted crop growth. This could lead then to not enough grain of our own to feed our animals or to sell for profit. That then led us to needing to buy grain from someone else. Many farmers in the area would be experiencing similar drought stress, which would lead to an increase in the cost of grain, and therefore buying grain would impact our family's income as well. Conversely, too much rain could also lead to a chain of cause and effect, as we discussed in our example from last week. In the world of Antarctic glaciology, we know that glaciers are changing, and this is an effect. Trying to understand the cause of this effect can be difficult work. As we discussed last week, the Earth is made up of different systems that interact with one another, and we know that there are many causes for melting glaciers. For example, changes in ocean warming, ocean currents, air temperatures, air currents, and precipitation can translate into huge changes in marine terminating glaciers, which, as a reminder, is where glaciers flow into the ocean. In 2016, Dr. Alison Cook showed this link between ocean warming and glacier front position and velocity very effectively when looking at the Antarctic Peninsula, which is my study site. This is a map of the Antarctic Peninsula where my study sites are located. On the western side of the peninsula, you can see that the ocean temperatures are in light blue and light red, with blue corresponding to colder and red corresponding to warmer temperatures. Here you can also see darker red and blue circles, with their size corresponding to larger or smaller glacier area changes. And in the case of red, the shrinking of glacier area. In the case of blue, the expansion of glacier area. As you can see, where there are warmer ocean temperatures, there are generally larger losses in glacier area and vice versa. It is this specific link between the ocean and glaciers on the Antarctic Peninsula that I am exploring more fully. Measuring how much icebergs are melting is a great way to determine what the conditions of the oceans are and how they are changing, as we learned from last week. We can also use satellite imagery to see how glaciers that end in the ocean are changing through time. The changes that I'm evaluating are changes in glacier front position, or also known as terminus extent, and glacier velocity. So, effectively, my scientific questions are structured around a cause and effect scenario. These questions include: are iceberg melt rates, which are a reflection of ocean conditions, or the cause, linked to changes in how glaciers behave on land, the effect? Do we see these changes in space or in different places across the peninsula? And do we see these changes over time? My research directly builds upon the work that Dr. Alison Cook did before me, but does so through the use of another method, using iceberg melt rates. This relationship between iceberg melt and glacier change can be applied to different locations and new contexts as well. The complexity of interactions between different systems or multiple aspects of one system are what makes interdisciplinary teams so valuable in trying to answer research questions, because working together and not separate makes the outcomes of research much stronger. For example, a team of scientists made up of people studying ice, interactions between ice and the ocean, and the ocean more specifically, can help us to answer complex questions that can't be answered by one scientist alone. Thanks for exploring cause and effect with me for my research around the Antarctic Peninsula. Next week, I'll be talking about stability and change over space and time for glaciers in the ocean in this region too. Some questions I have for you this week are, which other researchers who have done the Follower Researcher program in the past have investigated cause and effect in a different system? Can you give an example of how their research showed this cause and effect? Are you studying any cause and effect relationships in science right now? What are some examples of cause and effect in your everyday life? And do you have any other questions for me about my research? Thanks so much for joining me this week, and I hope this video, the cause, has helped you learn something, the effect.